All right, now you've mastered trig, right? You've mastered using SOHCAHTOA and solving for missing sides. So you have the ability to find a missing leg or a missing hypotenuse using any of the three trig functions, right? Sine, cosine, or tangent. However, now we know two of the legs, or we know the hypotenuse and leg, and we want to find the angle associated with it. So we're going to use inverse trig. Everything is very similar except it's just the algebra associated with solving for the angle. But the setup is the same. It's still sine, cosine, and tangent. They're exactly what they are. You write the same equations. Okay, so I want to find the angle, and the angle is this theta, right? That's our angle. It's our missing angle, but there is an exact triangle that makes an 8 and a 10. So let's think about this. First, let's pick the trig function. If I'm looking at that angle, this is opposite and this is adjacent. So that tells me I'm going to use tangent. Okay, so write that. Tangent of theta equals opposite over adjacent. And now we have a new thing on our calculator. We want to get rid of tangent. So really what you're doing is you're applying an inverse. It's no different than taking division and using multiplication, addition and subtracting, square roots and squares. They're all just inverse operations of each other, right? This isn't tangent times theta. This is tangent of theta. Tangent is a function. So you just do inverse tangent of it, okay? So just like, let me write this over here. Like if you had this, x over 3 equals 5. See how this is x divided by 3, and to get rid of the 3, to move it to the other side of the equation, you multiply by 3. See how you did the inverse operation, right? If you add x minus 4 equals 10, if this is a minus, you would add 4 to the other side, right? You'd move it to the other side using the inverse of subtraction, which is addition. Same thing here. You're going to move the tangent to the other side of the equation by using inverse tangent. Inverse of 8/10. And all you have to do is type that in your calculator. So calculator-wise, it's really easy, right? So if you find tangent, you're just going to see above, it's like a tangent inverse there. That's what that means, tangent inverse. Tangent to the negative first. Isn't a negative first power, it's inverse tangent. So second tangent, see how it gives you tangent inverse, and then just do 8/10. And hit enter. And it's going to say, oh, that angle is 38.7. So theta equals 38.7 degrees. Meaning if you have a triangle with a 38.7 degree angle there, I guarantee this is going to be in an 8 to 10 ratio. 4 to 5, 80 to 10. You don't know the size of them, but you know that that ratio is 8 to 10. Okay, so that's down here. Okay, that angle, this is the hypotenuse. That's opposite. What trig function relates the opposite and the hypotenuse? Well, that's sine. So sine of our angle is 5 over 11. So if you want to solve for the angle, you have to use inverse trig. So then theta equals inverse sine of 5 over 11. So bust out your calculator again. Inverse sine, right? Second sine of 5/11. And we get 27 degrees. Theta equals 27 degrees. Sweet. All right. This one, got the right angle there. If I'm talking about this angle, see how this is adjacent to it. This is the hypotenuse. Adjacent hypotenuse is cosine. Cosine of the angle is 7 over 12, right? Adjacent over hypotenuse. Well, if I want to solve for an angle, I'm going to use inverse. So then theta equals inverse cosine of 7/12. Type it out. Second cosine, 7/12. Enter. Theta equals 54.3 degrees. Okay, so now we kind of have all the tools. We can solve for missing sides using just normal trig, one-step or two-step algebra, or we can use inverse trig to find an angle. And then if you can find an angle, you can kind of find everything else. What if I just wanted to come up here and find this side? Well, I could have just done the Pythagorean theorem. Once I know this angle, don't I actually know the other angle? Because don't I know these angles add up to 90? Sure, right? Like for instance, if this is 27, this guy down here has to be 63 degrees because those two have to add up to 90 because the whole triangle has to add up to 180. So again, once you know one, you kind of know the other. Okay, so this is just an example. What if I just said solve the right triangle? So you got, all you know is that this is 40 degrees and this is 10. You don't know the other angle, you don't know the hypotenuse, and you don't know y. Well, there's so many things you can do. Let's go ahead and find y first. This is adjacent. This is opposite the angle. And I know that adjacent and opposite is tangent. So I'd say tangent of 40 is opposite over adjacent. Okay, is that one-step or two-step algebra? One-step algebra. The variable is right where it wants to be. It's already in the numerator. All we have to do is multiply by 10. So 10 tangent of 40 equals y, and we just bust that up and say 10 tangent of 40, and we get 8.4. So y equals 8.4. Okay, once we know y, well, we can actually just use the Pythagorean theorem. 8.4 squared plus 10 squared equals x squared. Okay, so I'm going to take the square root of 8.4 squared plus 10 squared, parentheses, and I get 13.1. So x, the hypotenuse, equals 13.1. And then what's the other angle? Well, if that's 40, that's got to be 50. So z equals 50. Because I know those two have to add up to 90. So I just did 90 and subtracted 40. So bingo, that one's done. I know all the sides and all the angles. Okay, let's come over here. Last one, and then we're kind of done with this sheet. So, okay, I don't know this side length, and I don't know either angle. Pick. Let's do x first, okay? So let's find the angle first. That's kind of fun. So I wanted to find this angle. Again, this angle is important that I've just selected this one because if I selected the other one, what's opposite and what's adjacent actually changes, right? So I'm taking this angle. This is the one next to it, and this is the opposite. Now, again, if I picked y, well, then this would have been adjacent, and that would have been opposite, but that's always the hypotenuse. So if I'm solving for x, I can say cosine of x. Cosine is adjacent over hypotenuse. And it turns out that I actually used the same triangle. I didn't mean to do that, but and again, how do we solve for an angle? We use inverse trig. So we would do second cosine of 8/10. And we're going to get 36.9. X equals 36.9. And if you actually notice, they actually weren't the same triangle. This was an 8 by 10 where the 8 and the 10 were the legs. This is an 8 and 10 where the 8 and the 10 is a leg and hypotenuse. So they're actually not the same triangle. They're close, right? 36 and 38 degrees, but they're not actually the same based on I changed things. Okay, so I know that. You know what I'm going to do? I'm going to find the other angle. I'm going to take 90 and I'm going to minus 36.9. I'm going to find the other angle. So the other angle y has to equal then 53.1 degrees. And I'm going to find this using Pythagorean theorem. Okay, 8 squared plus z squared equals, that's a z, 10 squared. So I'm going to take 10 squared, I'm going to subtract 8 squared, and then I'm going to take the square root of 36, and you're like, oh, that's actually easy, because the square root of 36 is just 6. And then check. I know everything about that triangle. Okay, so we solved some triangles, and we also used inverse trig. And again, if you're going to solve for an angle, you're going to do inverse trig. There are really only 3 possibilities when you look at a trig function. The angle can be the variable, the numerator can be the variable, and you do 1 step, or the variable can be in the denominator and you need 2 steps. Okay, so it's 1 step, 2 step, or inverse trig is everything you're going to do in this particular class. Okay, go ahead and try the inverse trig problems and the story problems.